Hello, children. Welcome to Right Tuition Classes. Okay, we're going to start with our math syllabus, first chapter, real numbers. Okay, now, of course, you have learned about numbers in your ninth standard. Okay, now just go ahead. Okay, and as and when required before the exercise, I'll be talking about the concepts also. So you need not worry, you will be able to understand it. Okay, now let's see here something, what do you mean by a lemma? Okay, what do you mean by lemma? A lemma is nothing but a theorem, what you learned in geometry. Theorems were a proven statement. पहले से वो prove किया गया है statements, okay? और वो theorem का मदद से बाकी statement को prove करते थे. Got it? That is what we did. So same thing, we just call it a lemma. Okay, the theorem is nothing but a lemma. So I'll say it's a proven statement used for proving other statements. It's a proven statements used for proving other statements. Are you getting me here? Got it? समझ में आया? जैसा theorem था, छोटे क्लास में आपने 9th स्टैंडर्ड में theorem पढ़े हो, और theorem क्या था? एक proven statement था. Got it? फिर उसका मदद से बाकी स्टेटमेंट्स हम प्रूव करते थे, तो वही थ्योरम का दूसरा नाम है लेमा. तो लेमा को हम लोग कैसे डिफाइन करेंगे? प्रूवन स्टेटमेंट which is used to prove the other statements. Are you getting me here? वैसे next, you should know what is an algorithm. Algorithm very important. Okay, what is an algorithm? It is a well-defined steps of procedure for solving a problem. मतलब एक मैंने आपको प्रोसीजर बता दिया कुछ सॉल्व करने के लिए, एक प्रॉब्लम टैकल करने का एक प्रोसीजर बता दिया, लेकिन बेटा मैंने प्रोसीजर बताया ना, आपको समझ में नहीं आ रहा है. तो अगर वो प्रोसीजर को मैं तोड़ के देता हूं और एक स्टेप बाय स्टेप, गॉट इट, और लास्ट स्टेप में वो प्रॉब्लम सॉल्व होता है. तो अगर मैंने वही प्रोसीजर को तोड़ के दे दिया मैंने step by step, तो उसको हम क्या बोलेंगे? Algorithm. Are you getting me here? So what is an algorithm? In English, it is a well-defined steps of a procedure. It is a well-defined steps of a procedure. Well-defined steps of a procedure for solving a problem. For solving a problem. I hope people are understanding. So what did I teach you? I taught you two things. What is a lemma? What is an algorithm? What is a lemma and what is an algorithm? Now what am I going to do, children? I'm going to teach you what is a lemma. Okay, one lemma. Example, not what is a lemma? I'm going to teach you one lemma. One lemma. Lemma मतलब एक theorem. Okay, आप पढ़ने वाले हो, जो आप एक थ्योरम करके नहीं, लेकिन पहले से आप जानते हो, छोटे क्लास में से जानते हो. खाली हम वो जो किए आपने छोटे क्लास में उसका नाम देने वाले हैं इधर. ओके, वो थ्योरम का नाम, वो लेम्मा का नाम देने वाला इधर, वो लेम्मा का नाम बताने वाला आपको. आपको मालूम है ये क्या है? जैसा let's see some simple examples on the left hand side. You can see on the screen. Can you see 15? This 15 is divided by 2. 2 7 times 14 I write, and what is remaining? 1. अब ये 1 आके 2 से कम है, इसके लिए ये जो 2 है ना, ब्लू में लिखा हूं, उससे कम है, तो आगे डिवाइड नहीं कर पाऊंगा क्योंकि मुझे डेसिमल नहीं चाहिए. ओके, वैसे अभी 27, दूसरे एग्जाम्पल देखो, 27 है, उसको मैं 5 से डिवाइड करना चाहता हूं. जो 5 से डिवाइड करता हूं तो 5 5 25, तो फिर से रिमाइंडर बच गया 2. आप क्या देखते हो? रिमाइंडर के ऊपर ध्यान दीजिए, प्लीज लुक एट द रिमाइंडर, क्योंकि रिमाइंडर ये जो 5 है उससे कम है, इसके लिए हम आगे डिवाइड नहीं कर पाते, रोक देते हैं डिवीजन को इधर. वैसे ही 58 है, उसको 7 से डिवाइड करना है. आई वांट टू डिवाइड दिस 58 बाय 7. 7 8 56. Okay, so what is the remainder? 2. Don't you agree? Remainder, इसको remainder बोलते हैं 2 को. Remainder less है 7 से, तो हम आगे डिवाइड नहीं कर सकते. तो ये जो आपने सीखा है उसको मैं, सबसे बड़ा नंबर, इसमें सबसे बड़ा नंबर क्या है बेटा? 15. Got it? वो अकेला लिखता हूँ लेफ्ट हैंड साइड में. देखो लेफ्ट हैंड साइड में जो बड़ा नंबर डिवाइड, जिसको डिवाइड करना है ना बड़ा नंबर को, उसको 15 लेफ्ट हैंड साइड में लिखा, बाद में इक्वल टू. गॉट इट? आप समझ सकते हो इक्वल साइन क्यों डाल रहा हूं. सो ये 2 है ना, 2 से डिवाइड किया, 2 into 7 प्लस ए रिमाइंडर. गॉट इट? सो 15 2 into 7 is 14. 14 plus 1 15. गॉट इट? वैसे 27 सबसे बड़ा नंबर 27 इधर, उसको अकेला लेफ्ट हैंड साइड में. बाद में ये जो ब्लू है, ब्लू वाला नंबर, उसको 5 into 5 25 plus 2 remainder. So 58 equals 7 into 8 56 plus 2. ये जो डिवाइड किया हमने उसको ये स्टेप में लिखा है. अभी मैं क्या बता रहा हूं, देखो बेटा, जो नंबर को ये जो रेड में मैं जो लिखा हूं, ये जो नंबर्स में रेड में लिखा हूं, ये जो नंबर्स इधर रेड में लिखा हूं या इधर दिख रहा है आपको रेड में, सर्कल में डाल रहा हूं, ये नंबर्स को हम क्या बोलते हैं बेटा? हम इसको डिविडेंड बोलते हैं. क्या बोलते हैं बेटा? डिविडेंड. क्या बोलते हैं इसको? डिविडेंड. गॉट इट? हम उसको डिविडेंड बोलते हैं. गॉट इट? ये जो ब्लू में लिखा हूं मैं, ये जो ब्लू में लिखा हूं मैं, दिख रहा है आपको? 5, इधर 2, इधर 7, इसको बोलते हैं डिवाइजर. क्या बोलते हैं इसको? डिवाइजर. कैन यू सी? इसको बोलते हैं डिवाइजर. कैन यू सी? सो डिविडेंड इक्वल डिवाइजर. ये जो मरून कलर में लिखा हूं मैं, उसको बोलते हैं, प्लीज अब लिखिए, इसको क्या बोलते हैं बेटा? इसको बोलते हैं कोशेंट. इसको बोलते हैं कोशेंट. इसको बोलते हैं कोशेंट. QUOTIENT, कोशेंट. कैन यू सी? और ये जो लास्ट में लिखा हूं बेटा, इसको बोलते हैं, जो बच गया, रिमाइंडर. मैंने नाम बता दिया इसको पहले ही, रिमाइंडर. इसको क्या बोलते हैं? रिमाइंडर. इसको क्या बोलता हूँ? रिमाइंडर. तो मैं इधर इन जनरल इसको क्या बोलते हैं? रेड में लिखा है कोशेंट, ब्लू में लिखा है उसको क्या बोलते हैं हम? डिवाइजर. मरून में जो लिखा हूं उसको क्या बोलूंगा मैं? कोशेंट. और ये ब्लैक में लिखा है रिमाइंडर. ओके, सो कैन आई राइट इट? डिविडेंड इज ऑलवेज इक्वल टू डिवाइजर इनटू कोशेंट प्लस रिमाइंडर. तो ये जो चीज है आपने छोटा क्लास में ही सीखा है. खाली बता रहे हैं ये जो चीज है आपको यूक्लिड ने सबसे पहला बताया था. यूक्लिड. करेक्ट? तो यूक्लिड ने सबसे पहला आपको ये जो चीज है यूक्लिड ने बताया था बेटा. तो इसको बोलते हैं यूक्लिड डिवीजन. डिवीजन हो रहा था ना, लेमा. यूक्लिड सबसे पहला यूक्लिड ने बताया. तो यूक्लिड को याद रखने के लिए बेटा यूक्लिड ने दिखाया था. ओके, इसके लिए इसका नाम ही दे दिया यूक्लिड. डिवीजन कर रहे हैं, डिवीजन लेमा. लेमा है, लेमा है. तो लेकिन अभी इंग्लिश में कैसे लिखेंगे? सपोज डिविडेंड और डिवाइजर, पहला से कौन सा दो चीज आपको पहला ही मालूम रहनी चाहिए? ये जो रेड में लिखा है डिविडेंड और ये जो ब्लू में डिवाइड, वो पहले ही मालूम रहनी चाहिए, तो ही आप आगे बढ़ सकते हो. गॉट इट? इसके लिए हम पहला क्या बोलते हैं? फॉर एनी टू गिवन, गिवन बोलते हैं उसको, पहले से ही मालूम रहनी चाहिए. फॉर एनी टू गिवन पॉजिटिव इंटीजर्स ए एंड बी दैट एग्जिस्ट, आप निकालते हो, दैट एग्जिस्ट अ यूनिक, दैट एग्जिस्ट अ यूनिक होल नंबर्स. अभी होल नंबर्स इसके लिए बोलते हैं, होल नंबर स्टार्ट फ्रॉम 0, 0 1 2 3, 0 भी आ सकते हैं इसके लिए. ओके, there exist unique whole numbers q and r. There exist unique whole numbers q and r such that a is equal to b into q plus r. But a r and r हमेशा it will be either greater than or equal to 0. r 0 आ सकता है या 0 से बड़ा आएगा, लेकिन हमेशा वो डिवाइजर से कम ही आएगा. डिवाइजर से कम ही आएगा. ओके, तो ये जो आप पहले छोटे क्लास में सीखे हो, ये यूक्लिड ने बताया था. इसको हम लोग अभी आप बड़े क्लास में आगे समझ सकते हो. इसका नाम क्या है इसका बाबा? यूक्लिड्स डिविजन लेमा. एंड हाउ वी पुट इट इन इंग्लिश? Okay, for any two given positive integers a and b, for any two given positive integers a and b, a greater than b, a greater than b. Okay, there exists a unique whole numbers q and r such that a is equal to bq plus r. Are you getting me? तो आपको ये डिविडेंड और डिवाइजर पहले से ही पता रहनी चाहिए. इसके लिए हम लोग बोलते हैं फॉर एनी टू गिवन पॉजिटिव इंटीजर्स a and b, there exist a unique whole numbers q and r such that this a is equal to bq plus r, but this r should be greater than or equal to 0, less than b. ये कंडीशन बहुत इंपॉर्टेंट है बेटा. r is always greater than equal to 0, less than b. ये कंडीशन बहुत इंपॉर्टेंट है. तो हो गया, पहला मैंने लेम्मा बताया था, एल्गोरिथम बताया था, बाद में एक लेम्मा का साथ आपको मैंने इंट्रोड्यूस कर दिया. इसको बोलते हैं यूक्लिड्स डिवीजन लेमा. क्या बोलते हैं इसको? यूक्लिड्स डिवीजन लेमा. वंस अगेन आई विल जस्ट से फॉर एनी टू गिवन positive integers, I use the word positive integers, for any two given positive integers a and b, there exists a unique whole numbers Q and R such that A equal B into Q plus R, where R should be greater than or equal to 0 and less than B. B means less than divisor. Got it? I hope everybody's understood this Euclid's division lemma. Okay? अभी हम लोग इससे आगे अभी algorithm का एक एग्जांपल देखते हैं. ये लेमा, ये दोनों में जो दे रहा हूं एग्जांपल यही यूज करना है भाई फर्स्ट एक्सरसाइज में. Got it? We are learning the concept of solving the first exercise. ये आपको समझ में रहने चाहिए तो ये फर्स्ट एक्सरसाइज इजी लगेगा. Got it? So the second, what I'm going to tell you is about an algorithm. जैसे इधर यूक्लिड्स डिविजन लेमा सीखे आप, अभी एक algorithm बताने वाला हूं. ओके, algorithm क्या है बेटा? वेल डिफाइंड स्टेप्स ऑफ प्रोसीजर. एक प्रोसीजर तो रहता ही है, लेकिन उसको हम लोग ने स्टेप बाय स्टेप कर दिया, तो वेल डिफाइंड स्टेप हो गया प्रोसीजर का फॉर सॉल्विंग अ प्रॉब्लम. उसको बोलते हैं algorithm. तो हम लोग एक algorithm पढ़ने वाले, और दैट algorithm का नाम है, Euclid's division algorithm. So this is one algorithm, okay, and it's given a name Euclid's division algorithm. एक algorithm सीख रहे हो बेटा, उसका नाम है Euclid's division algorithm. अच्छा, क्यों Euclid's division algorithm नाम है? क्योंकि यूक्लिड का अभी हमने एक यूक्लिड लेमा सीखा था, यूक्लिड्स डिविजन लेमा. वो ही प्रॉपर्टी इसका अंदर यूज होने वाला है, इसके लिए इसको यूक्लिड्स डिविजन एल्गोरिथम बोला गया है. ओके, लाइक यूक्लिड्स डिविजन एल्गोरिथम इज नथिंग बट अ प्रोसीजर फॉर गेटिंग व्हाट एन एचसीएफ. It's for getting an HCF of two positive integers. Any two positive integers A and B are there. I want to get the HCF of those two numbers. तो इधर यूक्लिड का जो लेमा है यूज करके हम लोग HCF निकालने वाले हैं दो नंबर्स का. इसके लिए इसका नाम है Euclid's division algorithm. So let's see this Euclid's division algorithm. I told you what is an algorithm. Algorithm is nothing but a step by simple, well-defined steps for solving a procedure. Step-by-step procedure for solving step-by-step procedure for solving a problem. So here I'm showing you the step one. What you should do. पहला दो numbers है, any two numbers are there, okay, जिनका मुझे HCF निकालना है. Suppose there are two numbers A and B, and A is greater than B. I want to find the HCF of this A and B. So I apply these steps now. Look, apply Euclid's lemma. What is Euclid's lemma? You know, okay. Apply Euclid's lemma to A and B and get the whole numbers Q and R such that A equal BQ plus R. And what is this R? Greater than 0, less than B. So this is Euclid's lemma you're applying first stage. Now, after getting Q and R, just check if R is equal to 0, then straight away you can say that divisor B is a HCF of A and B. Got it? But if R is not equal to 0, then again you're going to use the same Euclid's lemma, taking B and R. Euclid's lemma for B and R. You'll apply Euclid's lemma for B and R. Got it? Then step 3, I'll say continue this process. What you done in step 2, continue this process till you get remainder 0. I'll tell you that is step 2 should be done. Step 2, repeat step 2 again and again till you get your R equals 0. And once you get R equals 0, then the divisor at this stage, okay? Then the divisor at this stage, okay? Then the divisor at this stage, got it? That is stage when you get R equals 0, is the HCF of A and B. Are you getting me here? So here, the whole division, Euclid's division algorithm is mentioned, children. Now we are going to start after understanding this. समझ में आया रहेगा ना सबको? देखो बेटा, आपको एक HCF निकालने को सीखने वाले हो दो नंबर्स के बीच में. दो नंबर्स है A एंड B. A बड़ा है B में से. ये दोनों का HCF, हाईएस्ट कॉमन फैक्टर निकालना है आपको. तो इसको जो मदद करने वाला है वो यूक्लिड्स लेमा जो सीखे है ना आप, इसके लिए ये जो मेथड है HCF निकालने का, उसका नाम दिया गया है यूक्लिड्स डिविजन एल्गोरिथम, यूक्लिड्स डिविजन एल्गोरिथम। तो यूक्लिड्स डिविजन एल्गोरिथम में जो स्टेप्स है, सिंपल वे में बोल रहा हूं, स्टेप 1 स्टेप बाय स्टेप है ना प्रोसीजर। तो स्टेप 1 आपको क्या है, दो नंबर्स है ए एंड बी, ए बड़ा है बी से, तो आप पहला इसका यूक्लिड लेमा यूज कीजिए, वही डिविजन, और आप क्यू एंड आर निकालिए। Are you getting me? Whole numbers Q and R such that A is equal to BQ plus R and A R क्या should be greater than or equal to 0 or less than B. Now अगर R 0 आया रिमाइंडर, तो अब सीधा B को HCF बोल सकते हैं A and B का, B itself is the HCF of A and B. अगर R 0 नहीं आया, आप फिर से रिपीट करेंगे यूक्लिड्स लेमा ऑन B and R. बी एंड आर, बी बड़ा नंबर है, आर छोटा नंबर है, वापस डिवाइड करो बी को आर से, फिर से रिमाइंडर निकालो। अगर रिमाइंडर वापस 0 नहीं आया तो फिर से रिपीट, ओके, डिवाइजर एंड रिमाइंडर दोनों का अगेन यूक्लिड्स लेमा यूज करेंगे आप। करते करते प्रोसीजर टिल यू गेट आर इक्वल 0 आपको करना है। द मोमेंट यू गेट आर इक्वल 0, दैट टाइम at that stage the divisor जो था उसको हम HCF of A and B बोल सकते हैं, ओके। जिनको नहीं समझा बेटा, लिखा तो हूं, but with the sums I'm sure, okay, this is the concept required for exercise 1.1. So with exercise 1.1 I'm sure you will understand better, okay children. Now what is this exercise 1.1? Let's see. Exercise 1.1. Children, this particular exercise, maybe I'll put it like this, okay? Look at all the sums of the book. Okay, complete टेक्स्ट बुक को देखने के बाद मैं बोल सकता हूँ ये जो एक्सरसाइज है बेटा, अगर आपको समझा तो आपको बुक इजी लगेगा, क्योंकि ये मेरे ख्याल से यही एक्सरसाइज है, ओके। इसमें जो सम्स है थोड़ा डिफिकल्ट है, ओके, थोड़ा समझना जरूरी है बच्चे लोग के लिए, ओके। यू जस्ट फॉलो माय मेथड चिल्ड्रन, आई एम सो श्योर अबाउट इट। अगर मेरा मेथड आपको समझा तो आपका आसान लगेगा, ओके। आपको खाली ध्यान देना है, ओके, और लिखते सॉल्व करते रहना बेटा। अगर सॉल्व नहीं करेंगे, जैसा पॉज करके लिखिएगा, सॉल्व कीजिएगा, नहीं समझता है फिर से देखिएगा, लेकिन इस तरह से करते रहेंगे, सॉल्व करते रहेंगे तो ही आपको समझेगा। Got it? So please solve it. It's an advice to all the children. Please start solving with me. Okay? Make an attempt. Don't just try to listen. Don't try to hear. Okay? So now look here, children. Now, question says use Euclid's division lemma algorithm. I told you, children, to find HCF. दो number का HCF. So here, what am I going to do? Solution, children. Okay? See, I want to use here Euclid's division algorithm. So I apply step 1. Okay, what is the step 1 beta? Applying Euclid's division lemma, applying Euclid's division lemma to 135 and 225. So in that, which is a bigger number beta? That is A. The smaller number is B. So which is a bigger number? 225. 225. So आप क्या करेंगे? 225 को अंदर और 135 को बाहर. तो 135 ones are, this is a quotient, this is a dividend, this is a divisor. 135 ones are 135. तो क्या मिला आपको? 90. So applying Euclid's division lemma to 135. So what is that? Therefore 225 equal, what I got? 225 equal, I wanted to divide it by 135. So what I got, children? 135 ones are, and what is this? Remainder. Got it? So you can see I got this. Got it? Now look, this is the remainder. Don't you agree? ये remainder के 0 है? नहीं, but it is less than 135. इसको ये आके dividend है, 135 divisor है, remainder 90 है. Now you can see since the remainder equal 90, okay, which is not equal to 0. Okay, not equal to 0. Hence, applying Euclid's. Let's apply Euclid's. I'll say Euclid's division. नहीं डालेंगे तो चलेगा. Euclid's lemma 2. अभी कौन सा डिवाइजर था? 135. So 135 A बन जाएगा and B बन जाएगा 90. Got it? Use div. So what do you get, children? 135 divided by 90. So what do you get? 1's are 90. So you get 45. So what do you get, children? Again, you get therefore 135 is a bigger number, which is a divisor. 90 is a divisor into 1 plus 45. Again, what is the remainder here, beta? Again, remainder 45 is which is not equal to 0. Therefore, again here, since 45, remainder is 45, okay, not equal to 0. Again applying, I'm so sorry, children. Okay, again, applying Euclid's lemma to 90 and 45. Because 90 was the divisor, 45 was the remainder. तो ये जो डिवाइजर है और ये रिमाइंडर उनका ऊपर यूक्लिड्स लेमा. फिर से तो क्या होता है बेटा? देखो 95 equal 45 into 2 plus 0. Therefore, remainder. Now what you got, beta? You got the remainder as 0. Hence, here remainder R is equal to 0. Remainder is equal to 0. Got it? So once you get the remainder equal to 0, got it? मतलब अपना process इधर stop होगा, अपना procedure stop हो जाएगा. Okay? Since remainder equal to 0, hence 45 is the, okay, 45 is the, hence 45 जो divisor है, divisor 45 है ना, जिधर remainder 0 आ रहा है तो divisor क्या है? 45. Hence 45 is the HCF of, I'll write it here, okay, is the, I have no place to write, okay, is the HCF of which two numbers, beta? 135 and 225. I hope people understood this. Applying Euclid's division lemma to 135 and 225. So what do you get? 225 equal, I told you, in a rough, you can do this division. 225 to 135 se divide karo. 1s are 135, 90. So we write it like this in a form of Euclid's division lemma. That is, A is equal to B cube plus R. So A का जगह में 225, B क्या है? 135. 135 into Q क्या है? 1 plus R. Since remainder is equal to 90, which is not equal to 0. Okay, which is not equal to 0. You want, you can put it in words, but you don't want to put it in words, chalega beta, because the teacher also understands which is not equal to 0. Okay, remainder equal 90, which is not equal to 0. Got it? Hence, applying Euclid's lemma to 135, 90. What do you get? 135 equal, again divide करके 135 equal 90 into 1 plus 45. Therefore, since 45 is not equal to 0, okay, again applying Euclid's lemma, what I can say? Euclid's lemma to 90 and 90 and 45. So what do you get? Okay, 90 is equal to 45 plus 2, 45 into 2 plus 0. So here the remainder is 0. Hence 45 is HCF of 135 and 225. Okay, so what we learned. Okay, now we are going to learn HCF of, we have to find the HCF of 196 and 38220. I want to find the HCF of, okay, the second one. This was the first one, okay. Now the second one. What are the second one? Two numbers. The two numbers are 196 and what is this? 38220. 38220. The bigger number will be A. Smaller number is 196. Okay. Bigger number is A. So applying, first step, we should applying, okay, Euclid's lemma to 196 and 38220. 38220. Okay, 38220. Okay, I apply. So what I get, children? 38220 equal 196 divided by plus remainder. So come on, what is that you get? Let's try. Okay, 3838220. I'll just take, children, 38220 and 196. बेटा 0 को forget it and 6 को भूल जाओ. ये कितना जा देखने का, देखो कितना बार 19. Got it? When you try to divide it by, children, when you try to divide it by, okay, I'll just show it to you. Okay, you ordinary division. Okay, 196 ones are 196 because 196 twos are, it will become more than 384, 382. So naturally, what is this? 0. And here what? 9. And here what, children? 190. Got it? It remains 190. Got it? So when I get 190, children, can you? 190 is not divisible. So what do? You bring down to? Got it? So 196, again, when you try to divide it by 19 tens are 190. So ये 3 numbers है ना, less है, so 9 से देखेंगे. 9 6 are 54. 9 9s are 81, 86. 9 1s are 9 plus 8, 17. So when I do this, how much you get? 12 minus 4 is 8. 9 minus 6 is 3. 8 minus 7 is 1, 0. Okay, I get this 138. And now this is again, children, when I put here 0. Okay, so how much it will be, children? Not going. So 196. Sorry, 10 I can bring it. Okay, 0 I can bring it. So what is it? 5 times 5 6 are 30. 45, 48, 5 1s are 5. How much you get, children? You get it as 5. Yeah, I think some mistake I had done. Okay, 2 minus 2, 0. 18 minus 9, 7, 2, 190, 2, 0. Okay. This is 196. 9s are 9 6 are 54, 5 9 9 are 81, 86, 17. So 12 minus 6. 12 minus 4 is 8. 9 minus 6 is 3. 8 minus 7 is 1. 1380. Now when I multiply 196 by 5, 196 by 5, 5 6 are 30. 5 9s are 45, 48, 980. 38220 divided by 196. So how much you get, beta? Just see, check it. Okay, somewhere I don't know what mistake I done, but there's a big mistake I'm doing. Okay, it's such a simple division. Okay, see. 195, 196, I'll put it like this. 1 times 196. 12 minus 6, 6. 17 minus 9, 8, and this is 2, 186. So this is 2. Got it? Now, 76, 9 nines, how much it will be? Okay, 9. 9 6 are 54. 5 carry over 9 nines are 81, 86, 17, 64. Okay. So when I do this, 12 minus 4 is 8. Got it? 15 minus 6 is 9. Oh, this is 0. This is 0. 196 5s are 980. So now this is the remainder, children. What is the remainder? 0. So what I see, I can write that for 196, you can check it here, children. 19388 can be written as, okay, or I'll write it below. Okay, therefore 38, therefore 38220 is equal to 196 is multiplied by 195. 195, children. This is your B, Q. Okay, 195 plus 0. Correct? So what do you see, children? This was 388. This is your B, and this is a quotient, and the remainder is 0. So since remainder equals 0, R equals 0, since R equals 0, I can say 196. 196 is the HCF of the two numbers, okay, of 196 and what is that? 38220. Got it? Yeah, I need not do again and again. I got it here itself in the first step itself. By getting me applying Euclid's lemma to 190. Euclid's lemma was the division beta. बाद में ऐसे लिखने का. So remainder 0 आया. So I can say 196 is a HCF of 196 and 38220. Now I come to the third part. 867 and 265. I want to find the HCF using Euclid's division algorithm. कौन सा बड़ा है बेटा? 867. So first step आप ऐसे लिखेंगे, applying. I told you ना, it's a procedure. It's about algorithm, step-by-step procedure. So first step, applying. Okay, क्या? Euclid's lemma. Euclid's lemma to 867 and 255. So when you do it, 867 को आप divide करेंगे. 867 को आप divide करेंगे 255 से. So naturally, children, this will become 3 times when you look at it, doesn't it? Okay, 867 को you're going to divide it by 255. So 255, when I do it 3 times, okay, 4 times will be bigger. 3 5s are 15, 3 5s are 15, 16, 3 does are 6, 7. Okay, how much you get? 7 minus 5 is 2, 6 minus 6 is 0, and this is 1. Oh, 1, 0. Now, look at children, that means I can say you applying Euclid's lemma to this, what do you get? 867 equal, I'll write it here so that you'll not get confused, okay? What is that? 867 is equal to 255 into 3 plus, what is the remainder? 102. Now, since remainder equal 102, not equal to 0, hence applying Euclid's lemma. Now, Euclid's lemma to the divisor, which was the divisor 255 and 102, to 255 and 102. So again beta, 255 को हम लोग divide करेंगे 102 से. 102 2s are 204. तो हो गया 51. तो क्या आएगा बेटा? 255 is equal to bigger number, that is A is equal to BQ. B is what? 102. And Q is what, children? 2. And what is the remainder? The remainder is 51. Okay. Now, since again 51 remainder is not equal to 0, applying Euclid's lemma to 102 and 51. So what I'll get, children, this is the easiest, 102 is it divided by 51. 51 twos are, and what is that? Remainder is 0. Now here I'm not showing the division. Okay, I have to write this main division. अपने को खाली नाम के लिए बता रहा. Now, so don't you agree? Now, since remainder is equal to 0, hence the divisor, which was a divisor beta at this stage, 51. Hence, 51, I can say is HCF of what I can say is 867 and 255. So you can see here, children, this was we learned one algorithm, okay? Always you have to use apply what? Euclid's division lemma, every step, okay? That's what the name of it, okay? Euclid's division algorithm. So you have to use that algorithm and find the HCF. I hope everybody has understood it, okay? Little congested, but doesn't matter, children. You can get it, okay? Now, we go to the next. Children, question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is an integer. मतलब क्या मानना है? कोई भी positive integer लेंगे. अगर 1, जैसे integers. Positive odd integers are nothing but natural numbers, children. 0 भी नहीं आएगा. Positive odd integers. मतलब plus 1, plus 2, plus 3. मतलब they are natural numbers. जैसे 1, please have a look here. Set of positive odd natural numbers is 1, 2, 3, 4, 5, 6. Got it? Goes on. उसमें ये set of integers, positive integers. Got it? Now, उसमें odd integers कौन सा है? The numbers which cannot be divided by 2 are called odd integers. So 1, 3, 5, 7, 9 goes on. Now, all these numbers are in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. That is what you have to show. All these odd integers are in the form of 6q plus 1, 6 or 6q plus 3 or 6q plus 5. There are two methods, children. One is very long cut and one is shortcut. I'm going to show you the shortcut method, what most of the school teachers show. Got it? So, please have a look here. ये odd integers तो मेरे को मालूम है क्या है, लेकिन बढ़ते जाता है. So, I'll assume some variable, okay? So, solution में what I'll do is, instead of taking these odd integers, I'll say, let us consider a positive odd integer a. Got it? Or let a be the positive odd integer. A be the positive odd integer. या अलजेब्रा में जैसे लिखते हैं ना, let the positive odd integer be a. चलेगा वैसा, चलो सबको लैंग्वेज ही सफर करता है. मैथ्स काय को किसको काय के लिए मैथ्स डिफिकल्ट होता है, कभी लिखने का रहता है ना, बच्चों लोग को नहीं आता है. सो लेट अस टेक लेट ये ना 1 3 5 7 9, so I have to represent them by some variable. So let us take it as a. Got it? Because I want to express them. I want to express them as 6q plus 1, 6q plus 3. So let a be let the positive odd integer be a. Got it? Now one thing, children, मतलब a हो गया. Now use इन लोग पे क्या बोला बेटा? We have to use what? Euclid's lemma. We have to use Euclid's lemma. Euclid's lemma says a is equal to bq plus r, where a is the dividend, b is the divisor, q is the quotient, r is the remainder. I have to use this. So आपका ये जो odd integer है ना a, show that a positive odd integer is मतलब equal to of the form 6q plus 1. मतलब a जो positive odd integer है equal b का जगह में क्या है 6. Are you getting me here? 6 cube plus 1. Remainder की जगह में 1 है. Are you getting me? So that means I realize let the positive odd integer be a. B की जगह में क्या लूंगा? 6 दिया है ना. And here the divisor is 6. ये क्वेश्चन में दिया divisor should be taken as 6. Got it? Therefore, by Euclid's lemma, see here, A is equal to 6Q plus R, where R का कंडीशन क्या? हमेशा बेटा मैंने बताया R should be greater than or equal to 0 but less than the divisor. What is the divisor here? Less than B. B is the divisor. ये R का जो कंडीशन है ना वही मेन है बेटा. R का कंडीशन से आप याद रखने वाले पूरा सम. R का जो कंडीशन है R should be greater than or equal to 0 but less than B. So either R should be greater than or equal to 0 but less than 6. Are you getting me here? So let the positive odd integer be A. Here the divisor is 6. The question में divisor 6 दिया है बेटा. Therefore by Euclid's lemma का spelling में double M. Euclid's lemma, A is equal to 6Q plus R, where R is greater than or equal to 6 but less than 6. Or greater than or equal to 0 but less than, you can see here children, what it is less than, it is less than 6. This is a rule. By that, okay? Now look here, children. The R greater than or equal to 0, less than 6 implies R is equal to either 0 or 1, 2, 3, 4, 5. R is greater than or equal to 0 but less than 6. मतलब R is greater than or equal to 0. मतलब R can be 0 also. Got it? Or greater than 0. So R can be 0 or greater than 0. So R equals 0. This less than 6 implies R is equal to 0, 1, 2, 3, 4, 5. Therefore, now what I'm saying, children, just have a look here. When I consider, very important, children, try to understand. That means what I can do is, children, therefore, I can say A is equal to 6Q plus 0 I can have remainder, or A is equal to 6Q plus this next 1 can be the remainder, or A is equal to 6Q plus 2 can be the remainder, or A is equal to 6Q plus 4 can be the remainder, 3 can be the remainder, 0, 1, 2, 3 हो गया 4, or A is equal to 6Q plus 4 can be the remainder, or A is equal to 6Q plus 5 can be the remainder. I told you now, remainder, these are the possible remainders. Got it? So from here I understood A can be any of the 6. Got it? But A is even when A is equal to 6Q. 6Q plus 0 मतलब 6Q. 6 is divisible by 2. So 6Q is an even number or not? A is equal to 6Q is an even number. But A is an even number when A is equal to 6Q, or A is equal to 6Q plus 2. और उसको 2 add किया 6Q को, तो naturally it's going to be an even number. 2 common ना? Got it? Or A is even when A is equal to 6Q, or A is equal to 6Q plus 2, or A is equal to 6Q plus 4. Got it? In all these cases, you see A is even. Whereas I want to show that any positive odd integer, I want my A to be a positive integer, but RA is a positive odd integer. Hence A is equal, इसमें कौन सा true रहेगा? Hence A is equal to either it can be 6Q plus 1, or A is equal to 6Q plus 3, or A is equal to 6Q plus 5. Got it? Therefore, now can I say A का value अपने को मिल गया ना clearly. अरे, what I did. Okay. Therefore, got it? You can clearly see this answer I got. See, I repeat. Show that any positive odd integer is of this form. 6q plus 1, 6q plus 3, 6q plus 5. Okay? Where q is an integer. So listen, how we go about. Let the positive odd integer be a. Or a be the positive odd integer. A should be positive. I don't just say integer. I want my a to be a positive odd integer. So right now, let the positive odd integer be a. Here the divisor is 6. कैसे समझा बेटा? क्वेश्चन में से समझा. क्योंकि यूक्लिड्स लेम्मा में a is equal to bq plus r. So a is my number. It should be equal to 6q plus 1 you want. So 6 is a, you can see, divisor. So here the divisor is 6. So by Euclid's lemma, a is equal to 6q plus r. A is equal to bq plus r, 6q, where r should be greater than or equal to 0, but it should be less than the divisor. Divisor is 6. मतलब less than 6. Remainder है ना? Remainder हमेशा divisor छोटा. Now, if r is greater than or equal to 0, but less than 6 implies r equals 0, 1, 2, 3, 4, 5. So if I take all these values, therefore a is equal to 6q plus 0 it can be, or a is equal to 6q plus 1, or a is equal to 6q plus 2, or a is equal to 6q plus 3, or a is equal to 6q plus 4, or a is equal to 6q plus 5. But here, our a is an even number. Got it? But RA becomes even, a is even when a is equal to 6q, or a is equal to 6q plus 2, or a is equal to 6q plus 4. But RA is a positive odd integer. They are said in the question we are taken. Hence, it should be what you can see this. And bach gaya jo bhi even ne. Hence, a should be 6q plus 1 or 6 equal, a is equal to 6q plus 3 or a is equal to 6q plus 5. And this is what I wanted to show. Got it? A is of the positive odd integers of this form. Are you getting me here? So I'm sure, I hope everybody understood it. Okay? There's nothing in this sum. Even for the last time I say, show that any positive odd integer, koi bhi positive odd integer, is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is an integer. ये कंसेप्ट थ्रू आउट हमको यूज करना है, इसके लिए मैं यही आइडिया दिखा रहा हूं. नहीं तो मैं आपको हर एक इंटीजर ऑड इंटीजर लेके दिखा सकता हूं सेपरेटली. Got it? So what happens? Let the positive odd integer be a. So here the divisor is 6. कैसे समझा divisor? किसने बोला? अरे इधर 6q plus 1, 6q plus 3, इससे समझता है divisor is 6. So by Euclid's lemma, a is, I know, b is 6 na? So a is equal to 6q plus r. But we know the condition for remainder, yay main. R is greater than or equal to 0 but less than 6. But r greater than or equal to 0 less than 6 implies r is equal to 0, 1, 2, 3, 4, 5. So what happens? Therefore, R A is either 6q plus 0 or therefore the value of A is the value of A is okay. A is equal to 6q plus 0 or A is equal to 6q plus 1 or A is equal to 6q plus 2 और ये सब आएगा रिमाइंडर्स है ना possible remainders. But A is even when you see A is equal to 6q or A is equal to 6q plus 2 or A is equal to 6q plus 4. Even matlab they are even numbers. They can be divided by 2. Therefore, but RA is a positive odd integer. Hence, what will happen, beta? Hence, A is 6q plus 1, yeah, or 6q plus 3 or 6q plus 5. And we wanted to show this only. Okay, we got it. I hope people have understood it. Okay, little difficult, children. You read it twice, thrice, you'll get it. And if you pay attention to the next sums, you'll definitely understand. Okay, now I go to the next question, children, which is pretty easy. Only thing you have to be attentive. Same concept. I'm going to use the same concept, children. Okay, just understand, okay? Sure, question number 4. Okay, I should have done question number 3, but I'm doing question number 4 because same concept of question number 2. Beta, I told you that same concept, okay? If you understand, you may get around 4 marks. You can be able to solve any sum of this type. So try to understand. Use Euclid's division lemma to show that square of any positive integer. We know these are positive integers. 1, 2, 3, 4. All these are positive integers. Square of them. Okay, this squares of these positive integers, these squares, they are of the form 3m plus 1 or 3m plus 1 or 3m. You have to show this. Any positive integers are there, children? Not to worry, very simple. Any positive integers are there, 1, 2, 3. What are positive integers? You should know 1, 2, 3, 4 goes on. Now, if I think of the squares of them, like 1 ka square 1, 2 ka square 4, 3 ka square 9, 4 ka square 16, 5 ka square 25. These squares are of the form 3m plus 1. But how to show this? It is of this form. You have to use Euclid's division lemma. So let's go about, children. Now, try to understand, children. If these numbers are also divided by 3, 3 is a divisor here. 3 is a divisor. Understand? Okay, if 3 is a divisor and these numbers are divided by 3, like suppose 1 is divided by 3, okay? Now listen, I want the remainder as 1. Got it? Remainder, it is either of the form 3m, like, by m. 3m plus 1 is a remainder. Or if I divide this 4 by 3, got it? I should get the remainder 1. Or I should get the remainder, no remainder at all, 0. So let's try to understand this, how this is possible. I'm not trying to show you by this method. I'm just showing you the earlier method, what I did, where remainder, I told you, children, plays a very important thing. Because what is, again I repeat, see, Euclid's division lemma says, for any two positive integers a and b, a greater than b, this a is always equal to b cube plus r. लेकिन ये जो r का वैल्यू है ना, यही सबसे important है. R is greater than or equal to 0, but less than this divisor b. Less than this divisor b. Got it? Less than divisor b. तो यही मुझे सब में hint देने वाला है. So listen here, how I go about doing this, okay? So let's see here, children. Here, see how we tell. Let us consider any positive integer a. Let us consider a positive integer a. Let us consider a positive integer a. Got it? Now, what is the divisor? Divisor is 6. Divisor equals 6. You get it from divisor equal 3, sorry. Divisor equal 3. You get it from the question, okay? Divisor equal 3. Therefore, on dividing a by 3, let the quotient be q and remainder be equal r. Okay, therefore, by Euclid's lemma, division lemma, can I say beta a is equal to bq, matlab 3q plus r. Therefore, r is where r is greater than or equal to 0 and less than 3. Got it? So let us consider positive integer a. Now divisor is 3. So on dividing a by 3, I know I want square of that, but I'm talking about a first. On dividing a by 3, let the quotient be q and remainder be r. So by Euclid's lemma, a is equal to 3q plus r. Now look at R. Therefore, R is greater than 0, equal to 0 or less than 3. Now R, therefore, listen, try to understand. R greater than or equal to 0, less than 3 implies R is equal to 0, 1, 2, 3. 0, 1, 2, 3. Therefore, what I can say, your numbers, please have a look here. Your numbers are like, A is equal to 3 cube plus 1 plus 0. Or A is equal to 3 cube plus 1. Or A is equal to 3 cube plus 2. Got it? A, 3 cannot come. Plus 2, ज़्यादा से ज़्यादा. Therefore, cut it. A is equal to 3 cube plus 2 I can get. Got it? Less than 3, hai na? So now listen. Therefore, A is equal to 3 cube plus 0, or A is equal to, that is A cube equal to 3 cube plus 0 is 3 cube only, yeah? Or A is equal to 3 cube plus 1, or A is equal to 3 cube plus 2. Got it? So I got my number. These are my, A is a positive integer. A is a positive integer. What are these positive integer? I'm not taking 1, 2, 3, anything I take. See what I do. Here I want my divisor to be 3, I understood. So I'm dividing this A by 3 and I'm telling, let the quotient be Q and remainder be R. So by Euclid's lemma, A is equal to 3Q plus R. But what are the possible values of R? R should be greater than 0 or less than 3. I told you this is a key for the sum. So R ka matlab 0, R is greater than 0, less than 3 implies R is 0, 1, 2. R is 0, 1, 2. That means, therefore, what is A equal? A equal 3Q plus 0, or A equal 3Q plus 1, or A equal 3Q plus 2. Got it? And now you want to check the square, children. See the question. Show that the square of any positive. Now, square of this positive integers, let us check. Our A was a positive integer. It is either of the form 3Q or 3Q plus 1 or 3Q plus 2. Got it? So now I want A square. Okay. Therefore, A square equal, क्या आएगा बेटा? 3Q the whole square. Got it? Therefore, A is equal to, I repeat, 3Q plus 1, 3Q plus 0, 3Q plus 1, or A equal 3Q plus 2. I call them as 1, I call them as 2, I call them as 3. Now, A is equal to 3Q. So, I want the square of it. So squaring both sides. Okay, what I have done? This is actually squaring both sides. See, again I repeat, children. Now, these are my numbers. ये मेरा A मिल गया. Got it? लेकिन मुझे क्या show the square of any positive integer? I want to show the square of this positive integers. तो आपका पहला positive integer क्या है? A is equal to 3Q. Okay. Therefore, I want square of it. A square equal 3Q the whole square. I'll say this is from 1. Okay. So A square equal 3Q the whole square. So what I get implies, therefore, this is equal to 9Q square. This is equal to 9Q square. Got it? So equal to 9Q square. Can I write, please have a look here, can I purposely write this little common sense? 9 can be written as 9Q square. I'm so sorry. This is 9Q square. 9Q square. This 9 I can purposely write as 3 into 3Q square. So A square equal 3Q square. Now remember, please have a look here. Q is any integer. Q is say on dividing A by 3, let the quotient be Q and remainder be R. So R is so much, but Q is the integer. Okay. Now Q is what? An integer. Q is an integer. Hence, got it? Hence, 3Q square, 3Q square, 3 is an integer. Q square means the Q into Q. 3Q square is also a integer. Say M. Therefore, can I say a square equal 3m? Now, please have a look here. I want all squares. So now I'm talking about now, again, a is equal to 3q plus 1. A is equal to 3q plus 1. If you want, you can just say from, what is this? From 2. Okay, this is my statement number 4. My statement number 4. Now this is from 2. Squaring both sides, a square equal 3q plus 1 the whole square. Now a square, a plus b the whole square is a square plus b square plus 2ab. 3q the whole square is 9q square. 3 into a into b, 3 into 2q into 1, that is 2 into 3q into 1 is 6q plus 1. Now look at this, children. Can I see 3 is common, children? In the first two, 3 is common. Got it? In the first two, 3 is common. So can I write it as here 3q square plus 2q plus 1. Now here, again, see here, q is an integer. Hence, 3q square plus 2q is also an integer. अरे अगर उसका वैल्यू q इंटीजर है तो 3q square plus 2q is an integer. Are you getting me? Is also integer, say m. Therefore, a square equal, इधर क्या आएगा? 3m plus 1. I call this as 5. So here, square of a is 3m. Here, square of a was 3m. Here it is 3m plus 1. Now, there is one more form, okay? A is equal to, just here. Now, a is equal to, Aurika. Now, a is equal to, kya beta? 3q plus 2. So, squaring both sides, when you do, children, this is from 3. Now, squaring both sides, a square equal 3q plus 2 the whole square. So, क्या आएगा बेटा? 9q square plus 2 3 is 6q plus 4. Got it? Plus 4. Now, I got till here. So, what I do, I use little common sense here. See here, 9q square. This is where it is difficult. I purposely write 3 plus 1. Why did I split it as 3? अरे 3 पूरा common एक integer हो जाएगा. Now you see 3. So this will become 3q square plus 2q plus 1 plus 1. Now, see here, since q is an integer, hence 3q square plus 2q plus 1 is also a integer, say m. Therefore, क्या आएगा बेटा? आपका a square equal a with 3m plus 1 हो गया बेटा. ये हो गया statement number क्या? 6. Therefore, from 4, 5, and 6, we see square of a positive integer, is of the form 3m or 3m plus 1. Sure, children. I don't think the sum was difficult. फिर से एक बार हो जाएगा बेटा. Use Euclid's division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1. A positive integer is of this form. So what idea I do? Let us consider positive integer a. Now here, from here, I realize the divisor is 3. A positive integer, a square name, right? Positive integer. The divisor is 3. So on dividing a by 3, let the quotient be q. Q is, and remainder be r. By Euclid's lemma, a is equal to 3q plus r is greater than or equal to 0, less than 3, and q is an integer. Q is an integer, any integer, but q will be an integer. Now see, r greater than or equal to 0, less than 3 implies r ka value is 0, 1 and 2. Therefore, a ka different forms I realize. Therefore, a is equal to 3q plus 0. That is nothing but 3q. I call it as equation 1. Or a is equal to 3q plus 1. The remainder 1 I put statement number 2. Or a is equal to 3q plus 2. So I got a, this positive integer as this. 3q, 3q plus 1, 3q plus 2. Now what I do, I want to show that the square of any positive integer is of this forms. So what I do, a is equal to 3q from 1. So a square equal 3q the whole square, squaring both sides. 9q square. Can I write 9q square as 3 into 3q square? So what I did, see, I write an argument here. Q is an integer, hence 3q square is also a integer. And say m. So naturally, a square equal 3m. So I got a square as 3m. Now a is also equal to 3q plus 1. So again, squaring both sides. A square equal 9q square plus 6q plus 1. So I can see 3 into 3q square plus 2q plus 1. Now q is an integer, hence this whole thing. 3q square plus 2q is also an integer, say m. Therefore, a square equal 3m plus 1. Now a is equal to 3q plus 2, squaring both sides. So a square equal 9q square plus 6q plus 4. इधर एक super intelligence use करते हैं. ये जो 4 को ना मंगता करके I split it. This 4 I split it as 3 plus 1. Now why did I do that? So that I can, you can see here children, so that what happens is this, if I split it, ये तीनों में 3 common आ जाएगा. 3 common आ गया तो 3q square plus 2q plus 1 plus 1 as it is. Now I know q is an integer, so naturally the 3q square plus 2q कोई भी value डालेगा q का, ये भी integer ही बनेगा. 3q square plus 2q plus 2 is also an integer. So let us say n. So naturally a square equal 3m plus 1. So from fourth, you know what is fourth statement here? Square of the number. Again, you can see here a square. I didn't write it, okay? 1 minute. This is, therefore, this is make a common layer. Therefore, a square, sorry, a fifth, okay. Fifth statement, okay? The fifth statement, a square equal, what I get here? 3q square plus 2q plus 1. So a square equal 3m plus 1. Okay, you can check here, children. This is my fifth statement. A square equal 3m plus 1. And again, in the sixth statement, when I take a is equal 3q plus 2, you can see I get it as a square equal 3m plus 1. So from 4, 5, and 6, we see square of a positive integer is of the form 3m or 3m plus 1. I hope the concept was similar to the previous sum. Got it? Now, we go to another sum of the same type. See, children, question number 2. Then we did question number 4 and missed 3. Okay, I have to do 3. Question number 4. Then I'm coming to question number 5. Now, this 3, 4, and 5, almost the same concept. If this concept gets into your mind, children, you can solve any sum of this type. Are you getting me here? And this sum should carry either 4 marks or 5 marks. I told you initially, this exercise is one of the most difficult exercises of your book. So that is the reason, children. Okay, pay attention here, keep writing, try to understand. Okay, so yeah, use Euclid's division lemma to show that cube of any positive integer is of the form 9m plus 1 or 9m plus 8. You know, 1, 2, 3, 4. These are positive integers. Cube of 1 is 1 itself. Cube of 2 is 8. Cube of 3 is 27. Cube of 4 is 64. So likewise, for every positive integer, I can have their cubes. This cubes, I have to show it is of the form either 9m plus 1 or 9m plus 8. I have to show these cubes are either of the form 9m plus 1 or 9m plus 8. So what I do, children, I just like, please have a look here in my previous sum. Little adjustment we had to do because the divisor is 9. You can see divisor is 9. Divisor is 9, okay? So what I do, children, little I take care of, okay? Small place here. I want people, I'll be rubbing it off. I'll be writing also. I'll be rubbing also. So ultimately, so that you can understand better. See here, children, what we do is let the solution. Let the positive integer, let the positive integer be a. Let the positive integer be a. Got it? Let the positive integer be a. Now, look at children. Now, therefore, when now divisor equal 9, you can see. Let the positive integer be and divisor equal 9. So when I may have to rub this, don't when E is divided by 9, okay, let the quotient be B and quotient be Q, where Q is any integer, and remainder BR. When A is divided by 9, let the quotient be Q and remainder be R. Q is any integer and R is also an integer. Okay. Now what happens? Therefore, by division lemma, Euclid's division lemma, what will happen, children? By Euclid's division lemma, A is equal to BQ, that is 9Q plus R. Where, what is this condition? Where R should be greater than or equal to 0, but less than R. Less than 9, children, because the divisor is 9. Got it? Therefore, R, see, less than 9 implies, R greater than or equal to 0, less than 9 implies R is equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9. So क्या होगा बेटा ये step कितना आएगा? R is equal to 0, 1, 0, 1, 2. Now try to understand here. So don't it becomes a very lengthy sum. R is equal to here 9q plus 0, R is equal to 9q plus 1, R is equal to 9q plus 3, R is equal to 9q plus 4, R is equal to 9q plus 5. और बाद में सबका क्यूब भी करना है. फिर वो क्यूब्स को मुझे दिखाना है. It is equal to 9m plus 1 or 9m plus 8. It becomes a very lengthy sum. थोड़ा आप यूज करेंगे क्यूब है ना, क्यूब इसके लिए पॉसिबल है. See what happens if I do 3 cube. You know it is 9 into 3 into 9. मतलब 3 क्यूब में 9 हमेशा फैक्टर रहेगा ही. 3 क्यूब में 9 हमेशा फैक्टर आएगा ही. So since I'm going to make a cube of this numbers always, 9 रहेगा ही. So what I'm going to do is a small adjustment in this sum. Got it? So what I'll do, I'll say let the positive integer be A, and I'm going to take the divisor as, this is my common sense. I'm not going to take the divisor as 9. I'm going to take the divisor as 3, children. So when A is divided by 9A, when A is divided by 3, when A is divided by क्या आएगा बेटा? 3. When A is divided by 3, let the quotient be Q and remainder R. Therefore, by Euclid's division lemma, A is equal to क्या आएगा बेटा? 3Q plus r, where r is greater than or equal to 0 plus r is less than, it should be less than the divisor. What is the divisor here, children? 3. 3 is the divisor. So it should be 3. Therefore, क्या आएगा बेटा? R greater than or equal to 0, less than 3 implies R is equal to, क्या आएगा बेटा? R is equal to 0, 1, 2, less than 3. Therefore, A is equal to, either it will become 3 cube plus 0, or A is equal to 3 cube plus 1, or A is equal to 3 cube plus 2. 3 cube plus 1, or A is equal to 3 cube plus 2. You can clearly see. So once again, I say let the positive integer be A. Divisor is 3. I told you why. This is what I've done a common sense, because ultimately मुझे cube मांगता है. So when I do 3 cube, I'll get 27. So always 3 cube में 9 रहेगा. 9 can be called as a factor of it. Are you getting me here? So best idea I get, instead of going for 9, I say let the divisor, let the positive integer be A, divisor equal 3. So when A is divided by 3, let the quotient be Q and remainder equal R. Therefore, by Euclid's division lemma, I told you this. When R is greater than or equal to 0, less than 3, implies R can be 0, 1, 2. That means A is equal to 3 cube plus 0, or A is, so A is what? A is a positive integer, and you want a cube of positive integer to be shown like this. So now what am I going to do, children? I am going to take the cube of all this. Are you getting me here? Please have a look here. I'm going to take the cube of all this, okay? I call this as 1. I call this as 1. This is nothing but 3 cube. I call this as 1. I call this as 2. I call this as 3. Now you can see here. Now, when I take A as 3 cube, now A is equal to 3 cube, don't agree, from 1. So I want the cube of it, taking cube on both sides. Taking cube on both sides. So what will happen, children? This becomes 27 cube. But I can always write it as 9 into 3 cube. 9 3s are 27. 27 cube can be written as. So here, since q is an integer, hence 3q square is also an integer, It will also be an integer. If I put a value of q as any number, I'll get 3q square as a number only, which is an integer. Integer say m. Therefore, a cube is equal to 9m. Got it? Can I call this as 4, children? No. You got it? I hope, children, everybody is trying to understand me here. Okay? Here, one thing, and RB. See, where r is greater than or equal to 0, q is an integer. Q is an integer. Got it? We'll just write that. So, now look here. Yeah. Now, I want the cube of the second number. A is equal to, please here now, again, A is equal to 3 cube plus 1. You can just say, this is from 1, so this is from 2. Now, you want A cube, taking cube on both sides. Now, look at children. I'm just trying to show you A plus B, the whole cube will be A cube plus B cube plus 3AB into A plus B. So either A is the first term, B is the second term. So A का जगह में क्या है इधर 3 cube, B का जगह में क्या है 1. तो क्या आएगा बेटा इसका expansion? Okay, 3 cube the whole cube. Okay, plus 1 cube B cube plus 3AB. 3 into 3 cube into 1 into 3 cube plus 1. Got it? And what I'll get here, children, here, what I'll get? 27q cube plus 1 plus 9 plus, here, what is this? 3 into 3, 9. 9q into 3q is 27q square plus 9q into 1 is 9q. 9q. All the q are terms together, children. 27q cube plus 27q square plus 9q plus 1. इसमें पहला चीज में 9 कॉमन, क्या आएगा बेटा? 3q क्यूब प्लस 3q स्क्वायर plus q plus 1. Now, since, please have a look here. Since q is an integer, hence 3q cube plus 3q square, got it, plus q is also an integer, say m. Therefore, what do you get, children? Therefore, a cube equal, what is this? 3 cube plus 1 the whole cube. I got it so much. I can say 9m plus 1. I call this as y. Got it? In the same way, children, I can now I'm going to take a as, now a is equal to 3q plus 2. And here, little common sense I may have to use. See here, q, taking cube on both sides. A cube equal 3q plus 2 the whole cube. That will become 3q the whole cube, 27q cube, plus 2 cube, 8, plus 3 into 3 cube plus 2. That is 3 into 3 cube, 9 cube into 2, 18 cube, into 3 cube plus 1, 3 cube plus 2. I hope you understood me here. 3 into 3 cube, 9 cube into 2, 18 cube. So when I expand it further, children, 27 cube plus 8 plus 18 threes, 54 q square plus 36 cube plus 36 cube plus 36 cube. Can you see, children? Now what will happen? I'm going to do it like this, children. See here. This is, what I can do is 27q cube plus 54q square plus 36q plus, what will happen, children, here? This is 8. Okay, so this 8, I'm going to write it as, better, this 8, I'm going to, okay, plus 8 as it is, okay? No adjustment is here. 9 is common, 3 cube plus 6q square plus 4q plus 8. Okay, children? Now you can clearly see here, since q is an integer, hence 3q cube plus 6q square plus 4q is an integer, say m. Therefore, what will happen? A cube equal 9. What will it be, children? 9 cube. 9m plus 8. I call this as statement number 6. So what do you see, children? I'm going to rub this question. So you can clearly see now what I get. Therefore, just rub the question, children. We have read the question twice, okay, I'm sure. So now, what I can say is, therefore, from, what is that? 4. Just have a look at 4. Okay, 5 and 6. From 4, 5, and 6, we see, okay, the a cube equal, or cube, okay, a cube equal, that is cube of any positive integer, is of the form, I can say, is of the form 9m or 9m plus 1, not even 9m plus 1, or 9m plus 8, or 9m plus 8, okay? You have to show this. I hope people are getting me here. So here in this question, you have to show cube of any positive integer. You have to show it is of the form of 9m or 9m plus 1 or 9m plus 8. Got it? So I hope everybody has understood this question. This question is just like your other two questions, okay, children? And now I'm going to tell you one simple question, okay? One sum is left out, okay? Now what is that? Okay, we'll just say, what do you mean by prime numbers? Okay, see the number greater than 1, numbers greater than 1, and which is divisible by 1 and itself, is called a prime number, Please try to understand, children. See, I have to say number greater than 1. So remember, 1 is not a prime number. Number greater than 1 and which is divisible by 1 and itself. Like 2 is greater than 1. Got it? 2 is greater than 1 and it is divisible by 1 and itself. So 2 is a prime number. 3 is greater than 1. It's a prime number. 5 is greater than 1 and it is divisible by 5 itself. Okay, no other number can divide it. Greater than 1. 7, got it? Not 9, children. 9 is divisible by 3. 9 is not. 10 is not. 8 is not. 11. Okay, so it goes on. So prime numbers are what? Numbers greater than 1, which is divisible by 1 and itself is called a prime number. Got it? Whereas the next, what I want you to know is, why did I say prime number? Because from after knowing prime numbers, then only you can understand composite numbers. What do you mean by composite numbers? What do you mean by composite numbers, beta? Got it? Because the next theorem, if you want to understand, it's about composite numbers. See, the numbers greater than 1, but which are not prime, they're not prime numbers, okay, which are not prime. are called composite numbers. Are called composite numbers. Are called composite numbers. You understand, children? It should be greater than. It should be greater than 1, but which are not prime. So listen. 2 prime, 3 prime, nahi chalega, 4 chalega beta. It's not a prime number greater than 1. 5 nahi chalega, 6 chalega beta, 7 nahi chalega, 8 chalega beta, 9 chalega, 10 chalega, 11 nahi chalega, 12 chalega, goes on, okay? So the numbers greater than 1, but which are not prime number, which are not prime, are called composite numbers. Got it? So we are going to learn a very important theorem in the next lecture, and that is fundamental theorem of arithmetic. So for understanding fundamental theorem of arithmetic, you should know what is prime numbers and composite numbers. Okay, children? So with this, we end this lecture, children. Okay? Hello, children. Exercise 1.1, question number 2, question number 3, question number 2, question number 4, and question number 5. I've done it together because they had the same concept, okay? Whereas this question number 3 is something different, children, and very nice, very interesting, very easy, okay? And I want you to have a clear look at it, okay? Such an easy sum. An army contingent of 616 members. Army contingent, group of army, okay, of 616 members, each to march behind an army band of the 32 members. मतलब आर्मी का बैंड है 32 मेंबर्स के, वो पहले आगे मार्च करेंगे, उनके पीछे आर्मी का कॉन्टिजेंट, आर्मी का ग्रुप है जो 616 पीपल्स का है, वो पीछे ग्रुप मार्च करेंगे. The two groups are to march in the same group of columns here. They should march in the same number of columns. I'm so sorry, children. They should march in the same number of columns. They should march in the same number of columns. Just have a look at this number of columns, okay? They should march in the same number of columns. This is a biggest hint, okay? यही सबसे बड़ा important चीज है जिससे अपने को पूरा समझेगा. They have to march in the same number of columns. What is the maximum number of columns in which they can march? Maximum number कितना columns बन सकता है? तो देखो बेटा, वापस मैं बोलता हूँ, पहला बैंड जाएगा, उसके पीछे आर्मी जाएगा, कॉलम्स दोनों का, बैंड का जितना कॉलम्स है, आर्मी का भी उतना ही कॉलम्स है. गॉट इट? तो मैक्सिमम नंबर ऑफ कॉलम्स कितना रहेगा? देखो, टोटल बैंड में टोटल जन कितना है बेटा? खाली 32 मेंबर्स है, और आर्मी में 616 मेंबर्स है. So simple, children. I'll make you understand, okay? Before I go ahead, I just forget about the sum and just concentrate on what I'm telling you, okay? Look here, children. This vertical lines, what I'm drawing, okay? Like a grid, I'm drawing one grid, okay? The grid, इसको बोलते हैं network, a network को बोलूँगा grid. A grid network, okay? Now look here, I say red lines draw किया मैंने. ये red lines को बोलते हैं columns, okay? So in my notebook, the vertical lines, ये notebook है मेरा, vertical lines always represent the columns. And the sleeping lines, you know, the sleeping lines, horizontal lines, they always represent, sleeping lines always represent, this is a sleeping line, okay? This is a sleeping line. The sleeping lines, they always represent rows, ROWS. Got it? तो याद रखो बेटा, क्या मैं बोल रहा हूं? ये जो vertical lines है columns, the sleeping lines are called rows. Got it? तो अभी मेरा एक क्वेश्चन खाली एक ही है. Suppose, listen, हर एक, okay, ये जो है हर एक आदमी इधर खड़े हैं, okay? I'll make it like, you know, here these are the people standing, the black people, black are the people standing. Now, the complete like this, all columns and all rows, the people are standing. तो अगर मैंने आपको बोल दिया number of people standing in this, the number of people standing in this, got it? In this rows and columns, कैसे निकालूंगा? So I'll just tell you like this. Children, please have a look here. So simple. Okay, how many number of rows are there? 1, 2, 3, 4, 5. How many columns are there? 1, 2, 3, 4, 5. Oh, that means the number of people, how do you get? The total number of people, how do you get? The total number of people, you get it by doing number of columns multiplied by number of people. Number of columns into number of people. When you number of columns into number of rows, when you do it, how many rows are there? 1, 2, 3, 4, 5. How many columns are 1, 2, 3, 4, 5? Oh, 5 into 5. Kitna people are? 25 people are. This black dots represent the people. So did you understand this? Why? Just give you one simple example. Okay, the people are made to stand in rows and columns. Okay, the people are made to stand in rows and columns. Okay, so what is number of people? The number of people will be number of columns into number of rows. Are you getting me here? You should get this idea. समझा तो मैं आगे बढ़ूंगा, नहीं समझा तो नहीं बढ़ने लायक है. ओके, आई होप एवरीबॉडी हैज अंडरस्टूड. फिर से मैं बोलता हूँ, देखो बेटा एक ग्रिड है. ग्रिड मतलब कहते ये जो लाइन ड्रॉ किया हूं मैं नोटबुक में, ये वर्टिकल लाइंस है. वर्टिकल लाइंस को हमेशा कॉलम्स बोला जाता है, कॉलम्स. ओके, और ये जो स्लीपिंग लाइंस है, हॉरिजॉन्टल लाइंस है, उसको बोलते हैं रोज. ओके, तो आपने पीपल को, आदमी लोग को कॉलम्स एंड रोज में खड़ा किया है. गॉट इट? तो अभी इसमें कितना लोग खड़े हैं, तो आप कैसे निकालेंगे कितना लोग खड़े हैं? द नंबर ऑफ कॉलम्स मल्टीप्लाइड बाय नंबर ऑफ रोज will give you the total number of people. Okay, children, you understood this idea. Now I'm going to this. Okay, very simple concept. Look here. Now I'm saying an army contingent. Please have a look here. पहला ऐसा army एक मिनट. See, an army contingent of 616 people. Oh, total number of people दिया. आर्मी में कितना people है? 616. आर्मी का ग्रुप में कितना people है? 616. The members in is to march behind an army band. ये जो आर्मी का ग्रुप है 616 जन का, वो आर्मी का बैंड का पीछे मार्च करने वाले हैं. तो ये समझो आपका आर्मी बैंड है. ये समझो आपका आर्मी का बैंड है. दिस इज एन आर्मी बैंड. ओके, आर्मी बैंड. ओके, ये आर्मी बैंड खड़ा है. अभी इसके नीचे आप आर्मी के, प्लीज हैव अ लुक हियर, आप क्या बोल सकते हैं? आर्मी का ग्रुप को भेजना चाहते हो. इसके पीछे आर्मी का ग्रुप को भेजना चाहते हो. 1, ये रो एक कॉलम्स है, उनको भी कॉलम्स रोज का वे में खड़ा किया है. ये कॉलम्स है, ये कॉलम्स है, ये कॉलम्स है. ओके, नाउ दिस इज the army people, and they are made to, please have a look here, they are also made to march after the band. These are army people. Okay, these are the rows. What I'm showing you, these are the rows. These are the rows. Okay, so now I'm talking about, try to understand. Okay, very simple. ये आर्मी ग्रुप. ओके, एंड दिस इज द आर्मी बैंड. उनके पीछे ओके आर्मी बैंड आगे मार्च कर रहा है, आर्मी ग्रुप पीछे मार्च कर रहा है. द नंबर ऑफ कॉलम्स फॉर बोथ ऑफ देम इज सेम, 1 2 3 4 5, 1 2 3 4 5. बट रोज में अलग आएगा ही, बिकॉज इसमें खाली 32 पीपल है और इसमें 616 पीपल है. सो नेचुरली रोज कितना है, इसमें ज्यादा रोज आएगा बेटा. हमने तो ऐसे ही एक रफ डायग्राम ड्रॉ किया है. तो सपोज नंबर ऑफ कॉलम्स इज x, number of columns is x, number of columns. अगर आपको कितना कॉलम्स, अभी 1 2 3 4 5 मत गिनिए प्लीज, ये मैंने ड्रॉ किया है, लेकिन उन्होंने कितना कॉलम्स दिया नहीं है. सो लेट द नंबर ऑफ कॉलम्स भी समझने के लिए मैंने ड्रॉ किया, नंबर ऑफ कॉलम्स भी x, और इधर जो नंबर ऑफ रोज है, नंबर ऑफ रोज, इधर नंबर ऑफ रोज बी y. So what is this y? So what is the number of people in army band? X into y. But number of people in army band is 32. Matlab x into y is equal to 32. I hope people are understanding me. In the same way, the army people are marching behind army band. The number of columns is the same. Oh, number of columns is the same. मतलब ऊपर x था तो नीचे भी x है बेटा, लेकिन इसमें रोज ज्यादा ही आएगा. कितना रोज है मालूम नहीं, तो आप नंबर ऑफ रोज को z पकड़िए. तो इसमें इसमें कितना टोटल नंबर ऑफ पीपल इन आर्मी विल बी x into z, बट दिस x into z is 616. तो अभी देखो ऊपर x into y is 32, x into z is 16. ये x and y को फैक्टर्स ऑफ 32, x and z को फैक्टर्स ऑफ 616. तो ये x क्या बोला उन लोग ने, व्हाट इज द मैक्सिमम नंबर ऑफ कॉलम्स, इज मैक्सिमम नंबर ऑफ कॉलम्स है x. एकदम बड़ा नंबर मांगता है, कॉमन भी मांगता है, बड़ा भी मांगता है. दैट मींस x is nothing but highest common factor of 32 and 616. I hope everybody understood here. Yeah, I'm going to solve it. Children, please have a look here. The maximum number of solution here, just to help you understand, I showed this what is there on the right hand side. Now here I'm just showing the solution. Okay, let the maximum number of columns in which the army band and army contingency march be x. Okay, so therefore, since number of columns, maximum number of columns is required, since maximum number of columns are required, okay, hence x is HCF of 32, which is nothing but number of people in the army band, and 616, which is nothing but number of people in the army contingency. Okay, so x is nothing but HCF of 32. How to find this x, children? Therefore, by applying Euclid's lemma to 32 and 616. तो कौन सा बड़ा है बेटा? 616 बड़ा है. So क्या आएगा? 616 equal, okay, 32 into this 32. Okay, so when you divide this 216 by 32, how much you get, children? 216 by 616 by 32. When you do it, it is 32 into 19. When you divide, 19 is a quotient, and 19 2s are 38, 3 carry over, 19 3s are 57 plus 3, 608 हो जाता है. तो कितना बच गया बेटा? 600. This will be like, you know, when you look at 619, 18, so how much will be remaining, beta? 8 will remain. Okay, 618, 608, so 8 will remain. 8 is the remainder. Okay, now don't you agree? Now since 8 is not equal to 0, hence applying Euclid's lemma to 8 and 32. So what I see, 32 is equal to 8 into 4 plus 0. Now here, since remainder equals 0, hence I'll rub it off, children. I hope people have understood what explanation given on the right hand side. Okay, I'll just rub it off here. Okay, so what will happen, since remainder equals 0, we can say last non-common, what is a divisor? Last divisor 8. So we can say since remainder equals 0, the last divisor, okay? Since remainder equals 0, the last divisor 8, the divisor 8 is the highest common factor of 32 and 616. Hence, I can say HCF was nothing but the number of columns. Hence, maximum number of columns is equal in which army band and army contingency march is equal to 8. Got it, children? So there was nothing. I should not have taken it as X, but purposely to help you understand. Okay, IZ, X is HCF. So therefore, got it? Therefore, X is equal to what I can say? X is equal to 8. Okay, the hence maximum number of columns in which army band and army contingency march is equal to 8. A very simple sum. I'm sure, children, you have understood it. Okay, unique sum, different type of sum, but I can make many sums like this. Okay, so if your concept is clear, children, you can solve any type of sum. You need not get frightened that this chapter is difficult. Okay, any other children?